is called a shift table. Okay, so it is called a shift table. So here we are working on an ECG related table. Okay, so ECG interpretation. So ECG will be interpreted as whether it is normal or abnormal. So if it is abnormal, they will check whether it is a clinically significant abnormality or whether it is not clinically significant. So in this table, we are interested in seeing the subjects, how the result is changing, how the interpretation of ECG is changing from baseline to post baseline. Okay, from baseline to post baseline. If we see, okay, let me try to annotate it. Okay, so here the first important, let's try to take a look at the components. Okay, so the first thing is this is a shift table. So what is a shift? So the change from one particular time point to a second time point. Okay, so second time point. So the shift is the change from one time point to another time point in one particular result variable. Okay, here we are interested in seeing the difference between how the result is varying from baseline to post baseline. Okay, so across different time points. Okay, across different time points. So this is from ECG domain. Okay, the second thing is we are working on the parameter which is called as interpretation from ECG data. Okay, and the third component is we have to generate this table on safety analysis set. Okay, on safety analysis set. Okay, so and let's see the table structure now once. So here it is saying it is baseline result, the baseline result, and after that we have our treatment groups. Okay, we have our treatment groups. So what are the two treatments available in this data? So we have two treatments, they are active and placebo. So we don't have a total grouping. Okay, so this becomes our fifth component. Okay, fifth component. Okay, and next is we have to identify the time point variable. So what is the variable which holds the time point? And again we are using a result variable which is called post baseline result. Okay, and but however we have earlier seen only the examples where we have presented the treatment groups as columns directly. But if you see here, so within the treatment group we have additional columns. So for under placebo now we have three columns. What are they? The normal, abnormal NCS and abnormal CS. So what, how is this grouping coming now? So we have a combination of our treatment group within our baseline result. So we have two variables information is being presented as columns. Okay, the baseline result in combination with the treatment. Okay, so we have three baseline results possible. One is normal, second one is abnormal NCS and abnormal CS, and we have two treatment possible. So how many total columns are possible in this way? So two treatments multiplied by three baseline result values. So they are abnormal, normal and NCS. So we have total six columns presented here. Okay, we have total six columns presented. So what is the next thing that we generally take a look at? So we take a look whether these values are part of our variable of a variable or whether they have to be processed independently. So in most of the time, the time point variable values will be coming from a variable. So we can do our by group processing to get this counts for the unique values present in that variable. Okay, and this thing is also, these are also the values within another variable. Okay, so there is no need of any independent processing for each group. Okay, so here we can just group the result within time point for the post baseline result. So as these are part of the values of a variable. Okay, and what is the next thing? So we are grouping our headings as well. Okay, we are grouping our headings as well within each treatment. Okay, within each treatment. So these are also values within another variable. Okay, these are also values within another variable which is our baseline result. Okay, baseline result. And what are the two statistics which we are obtaining here? The two statistics which we are obtaining here are n, the number of subjects. Okay, number of subjects And the second thing is we are obtaining the percentage. We are obtaining the percentage. The percentages are calculated here based on the number of subjects available in that treatment. Okay. The percentages are being calculated here in this example based on the number of subjects available in this treatment. Okay. So this becomes our eighth component and ninth component. Okay. So we have these many counts. So what does this number 4 mean here? So there are 4 subjects who has a normal result at week 4, okay, in placebo treatment with a baseline result of normal 4. Okay. So what does this 9 indicate? What does this 9 indicate? What does this number 9 indicate? So at week 4, there are 4 subjects with abnormal NCS result, okay, with abnormal NCS result who had abnormal NCS result at baseline in the treatment placebo. Okay, we are being asked to generate the numbers in this fashion. Okay, so what will a reviewer know when they see this number 2 here? Okay, so they'll know like there are 2 subjects at week 4 who has a abnormal clinically significant result. Okay, who has a abnormal clinically significant result in placebo arm, but whose baseline result is abnormal clinically significant. Okay, whose baseline result is abnormal and clinically significant. Okay, so what does this number 1 indicate? Okay, what does this number 1 indicate? So there was a subject whose baseline result is abnormal NCS, okay, but has become normal at week 12. Okay, but has become normal at week 12. Okay, so this is how this table has to be reviewed or interpreted. Okay. Okay, let's go to our data. Okay, so I have the data included present in my folder. So I have used my shift right click to copy the path. Okay, to copy the path, and I have pasted it here, and I am calling that SAS program which has the data lines in my SAS program using percent include. Okay, so using percent include. So okay, I have saved the program. Let me write something. Okay, let me clear my work library. So how do I do that? I can use my proc datasets. Library is equal to work. Okay, and mem type is equal to data kill. Okay, if I am working in my PC SAS version, okay, so I can clear my log and lst using this command. Lst is my output window. Okay, output window using this command. Okay, so this way I'll have my log window cleared because I have some content here. I have some content here in the output window. So this command clears whenever this command is submitted. Okay, so the log window would be cleared, output window cleared will be cleared. So when I submit this code, all the data sets saved in the work library would be deleted. Okay, so we have this thing. So what is the general thing we generally do? So let's try to examine our descriptor portion. Okay, let's try to examine the descriptor portion of. Okay, let's run and see what are the data sets we have. Okay, so we have 2 data sets. The first one is ADSL, which has 41 observations. So what is the structure of ADSL? We'll have 1 record per subject in our analysis data set of subject level. Okay, and subject level analysis data will only have 1 record per subject. So what does this 41 observations mean? So we have 41 subjects in this study. Okay, so we have 159 observations in our data set called ADEG. What does that mean? So as we may have multiple collections for a subject, because the ECG can be taken at multiple time intervals. Okay, so a subject may have one or more than one records in ADEG, but there can be few subjects who do not have an ECG assessment at all. Okay, in that case, we will not have any record for that subject in ADEG, but okay, so for the subjects who have more than one ECG collection, so we can have more than one record in this data set. Okay, let's see the descriptor portion. Which procedure do we use to check the descriptor portion? We use our proc contents. Okay, proc contents. So first data set is ADSL. So I am using the keyword varnum so that I can see the variables metadata in the order in which they are created in my input data set. Okay, so I'm running code. Okay, so this is the metadata for my ADSL dataset. Name of the input dataset is ADSL. I have 41 observations with 3 variables in it. Okay, so with 3 variables in the dataset. What are the variables? What are those 3 variables? The 3 variables are U subs ID, so the treatment variable, and the safety flag. Okay, the safety flag. Okay, let's take a look at the metadata of our ADEG. So what are the total number of observations? So we have 159 observations in total, but 8 variables with 8 variables in it. Okay, so let's take a look at what are those 8 variables and what does each information convey. What does each variable convey? The first thing is U sub JD, the subject on which the ECG performed. Okay, the second thing is, so there could be multiple parameters collected as part of ECG. Okay, as part of ECG, there are different intervals. Okay, there are different intervals like PR interval, QT interval, QRS interval. Okay, but here we are only interested in the overall interpretation of the ECG. So in this data we only have that interpretation parameter. Okay, so here the variable conveying what is the parameter of that record. Okay, so we have the short version of it, which is captured in the param CD variable. Param is parameter, CD is code. Okay, so that's why we have the label of parameter code. So param is the descriptive text for the short version of the param CD. And similarly, we have as the ECG is being collected across different time points. Okay, so we need a variable to capture the time point as well. So we have 2 variables related to the time point. One is the character version, which is analysis visit, and we have a corresponding numeric variable associated with the a visit variable. Okay, which is a visitant. Okay, these 2 variables will have a one-to-one relationship. Okay, a one-to-one relationship. So and as we are like we have the interpretation of ECG, the result is stored in the value in the variable eval_c. Okay, the result, the interpretation result is stored in a variable called eval_c. So this is character analysis value. Analysis value is nothing but our result. Okay, we also have our treatment variable and also the flag indicating whether that subject is a part of a safety population or not. Okay, so let's go back and try to annotate. Okay, try to annotate our so we do not have anything to annotate here. This is a concept of shift, so we are interested in seeing how the result is varying from one time point to another time point. Okay, so how do we subset this interpretation? We have to use our param variable ADEG. So as we may have multiple parameters, we have to subset the parameter of interest. Okay, so we can make use of the ADEG param CD or param variable. Either of the variables, these 2 variables will also have one-to-one relationship. Okay, so we can use either param CD or param to subset the required parameter. Okay, as I mentioned that there may be different parameters available in an ECG data. So if there are multiple parameters, so we have to subset the parameter which corresponds to the interpretation, overall interpretation of the ECG. Okay, so we can make use of our ADEG param variable to subset the interpretation. So in this table has to be generated on safety analysis set. So which variable do we generally consider? So we consider our okay. So we consider okay variable AD SAFFL from AD SL data set. Okay, as this table has to be generated on safety set. Okay, so which variable do we have the time point information? In ADEG, we have a variable called a visit. Okay, a visit or a visit n. Okay. So let me notate the variable which is required for the time point identification, which is our ADEG a visit. So in which variable do we have our post baseline result? So there is only one variable which is called result. Okay, which is called result. So that variable itself will give us, okay, ADEG. There is only one variable, okay, okay, called eval c. Okay, eval c. But how do we identify whether a record is whether the result is a post baseline result or not? We can make use of our result variable in combination with our visit variable. Okay, so wherever the visit is post baseline, like the week 4, week 12 and week 16 corresponds to our post baseline results. Okay, post baseline time points. So this post baseline result indicates that the result on the records which are collected post baseline. Okay, results which are collected post baseline. Okay, so we do not have a direct variable to capture the post baseline result, so we have to subset the records which correspond to the post baseline time point and use the result variable there. Okay, AD, maybe let me put, okay, okay. So and next thing is we have this baseline result. Okay, so do we have a separate variable for baseline result? No. Okay, so it is only the result available on the baseline record. The result available on the baseline record. Okay, so the same thing. So this is with ADEG eval c on the baseline record. Okay, so which variable do we have our treatment information stored in? So we have our treatment information stored in a variable called TRT01AN. So TRT01AN. So we can use our ADEG TRT. So we can, let's use our ADSL TRT01AN. Okay. So now we have identified our, okay, input variables and input data set which are to be used to generate this table. Okay, which are to be used to generate this table. Okay, so I have the data stored in an Excel file and just try to, okay, just try to see how this works. Okay, now here is our ADAG data set. Okay, so we need to identify the counts. Okay, so for example, when we are trying to fetch the counts for, okay, placebo, normal, okay, at baseline versus normal at post baseline in week 4. Okay, so how do we get that? So we have to identify the subjects who have normal result at baseline. Okay, so normal result at baseline. Okay, I'm just filtering for the, so okay, these are the subjects who have normal result at baseline. Okay, so let's try to filter for treatment 1, which is our placebo group. Okay, so how many subjects do we have? So 1, 2, 3, 4, 5, 6. Okay, so we have 6 subjects who have a normal result at baseline. Okay, we have 6 subjects in placebo treatment. Okay, we have 6 subjects in placebo treatment. Okay, at which who have normal at baseline. Okay, but why do we have this as 4 here? Okay, so here we are interested in checking. Okay, so we have total 6 subjects which are qualifying for this column. Okay, placebo, normal. So there are 6 subjects who are being okay, classified as normal. Okay, so let's take a look at, okay, let's take a look at the subjects. Okay, I don't know. Okay, so checking this way, okay, normal at baseline, and then again filtering for the week 4 records. Okay, week 4 records. So do we have same number of subjects? Okay, let's just do one thing. So let's populate this baseline result across all records. Okay, let's populate this baseline result across all records of this subject. Okay, across all results of each subject. Okay, I have done that here in ADAG03. Okay, I have done that here in my ADAG. So I am creating a variable called base C. Okay, I am creating a variable called base C and populating the result which is present on baseline record across all records of that subject. Okay, across all records of that subject. Okay, so let me hide these two columns. Okay, so now I am interested in, okay, let me remove this two columns as well. Okay, now I am interested in identifying, okay, I am interested in identifying the subjects, okay, who have a normal result at baseline. Okay, this is baseline result. Okay, normal result at baseline in treatment 1. Okay, normal result at baseline in treatment 1 with normal result at post baseline at week 4. Okay, okay, we have 4 subjects if you see. So this is what we are trying to do here. So what did I do? So I have populated my baseline result. Okay, this is the baseline for this subject 111401. Okay, so this is the baseline result. I have populated this result across all records of that subject. Okay, how many records we had? We had 3 records. So this result is being populated across all records of that subject. Okay, so we have already identified, like in the input data itself, we have the visit which is clearly marked as baseline. So I am not rederiving my baseline, but I am using my result which is available on that record which is being called as baseline record and populating it across all records. Okay, so similarly, let's say for this subject. Okay, so what is that subject? 33333. Okay, DEAA 3003. Okay, so why do we have the base C missing? We do not have any record for that subject with visit as baseline. Okay, we do not have any record for this subject with visit as baseline. That's why we cannot populate the base C variable. Okay, so if you see, take a look at this subject 40001. Okay, so what is the baseline record? So result in the baseline variable, it is normal on the visit where it is baseline. So we are pulling this variable's value and populating it across all records of that subject. Okay, across all records of that subject. So that way, so we can do a cross tabulation between our result and baseline result. Okay, and then baseline result which would give us the counts. Okay, which would give us the counts. So let's take one other case. Okay, so placebo who has abnormal NCS result at baseline and normal at post baseline. Okay, normal at post baseline. So the requirement is abnormal NCS at baseline. Okay, abnormal NCS at post baseline. Okay, in treatment 1. Okay, in treatment 1 and normal result in week 4. Okay, so you see we have one subject. So this is what we are getting here in this output. Okay, so in order to do this, what should we do? Okay, in order to get this done. Okay, so get this structure. So we have the baseline result as a record now in our input data set. We have to populate our baseline result as a column, in our data set, just like what we did here. So let's try to do the processing in SAS. Okay, we have identified the variables. Okay, and we have also annotated our structure. Okay, so what is the first thing we generally do when we are given a task. We read the input data sets and filter for the appropriate records. Okay, so appropriate records, read and process input data. Okay, so what is our input data set? ADEG. So I am reading my ADEG. So what is the subset I have to use? I have to filter for my parameter. Okay, so we have param cd value as INTP. Okay, INTP. Okay, before that, if you are interested in checking the unique values within each variable of interest, what do? We can use our procfreq. Okay, procfreq variable, and along with the table statement I can check the unique values. So I am interested in checking the unique values in param cd. I am also interested in checking the unique values combination in avisiton and avisit. I am also interested in checking, I am also interested in checking the unique values available in the result variable. Okay, so these are the three components which are becoming our input. So the first one is parameter, the result variable, and the time point variable. So let's take a look at the unique values in these variables. Okay, so from ADEG. Okay, so let's use our list option such that. So now you see. So how many unique values are there in the param cd variable? It is only one, because I have given only the subset of the parameters from entire EDEG which is required for this table. So we only have one unique value in the param cd variable that corresponds to our interpretation parameter. So all the records have the same value of INTP. Okay, and so we have how many unique values in the visit combination? So visit, a visit, and a visit. So as these hold one-to-one relationship, so we have 1, 2, 3, 4, 5. Okay, so we have 5 unique values. The first one is screening, the second one is baseline, third one is week 4, fourth week 12, and fifth is week 16. So any visit which is on or after week 6 is after visit and 6 is our post baseline result. Okay, so this result with a visit is equal to baseline on this record would become our baseline result. Okay, so for this table we are not interested in this screening result. Okay, this we are not interested in this screening result. Only the baseline result has to be merged back onto these records, post baseline records, and then get the counts. Okay, so what are the possible values in our eval C? The result value variable it holds, like as we mentioned, that interpretation would be determine whether it is normal or abnormal. If it is abnormal, there are two levels within it, whether that is clinically significant or not clinically significant. Okay, so we have seen what are the unique values in the variables. So, and the second thing is we have to filter for our safety population. Okay, we have filtered the required parameter, and we have also filter for our required population. So the safety population and the parameter is interpretation. So let's try to create a variable called treatment to hold the values in this variable TRT01AN. Let's try to create subset our required records from our ADSL dataset as well. So what are the filter conditions we have to use? So we have to identify the safety subjects, and let's try to create a common variable name called treatment to hold the treatment values. Okay, to hold the treatment values from ADEG and ADSL. So we have done this. So what is the next thing we generally do? So we have to present our total number of subjects in this treatment, okay, here as a symbol, okay, as a macro variable, and also to use this number, total number of subjects in this treatment, as denominator. So we have to fetch our denominators. Let's try to fetch our treatment totals. Okay, treatment totals. So what does treatment indicate? We are just counting the total number of subjects available in each treatment. Okay, I am using my procfreq data is equal to ADSL01. Can I use my ADEG dataset to get the total number of subjects available in a treatment? No, because I may not have, say for example, for subject 101. So that subject is part of safety, but unfortunately there is no collection for that subject in ADEG. So, but I have to count that subject under that treatment as part of safety population. If I use my ADEG dataset as there is no record for that subject in ADEG, so I would be using a lesser number as denominator. So I cannot use my ADEG dataset as I will only have all the records, all the subjects in my ADSL dataset wherever I am being asked to get the total number of subjects within a treatment. Okay, I will have to use my ADSL dataset alone. Okay, so I'm using my table statement to get. So let's create a dataset called TRT totals. Okay, so to hold the total number of subjects available in each treatment. What would be the record structure when I apply this syntax? So I would get the variables, so which are present in listed in the table statement. So I am listing the treatment. So what are the two automatic variables which I get? The one is count and the second one is percentage. So I am not interested in the percentage variable which is being generated by this procfreak, but I am only interested in the renaming the count variable, because the count on this data set is nothing but my denominator. So I am renaming my count as denominator. Okay, or okay, so let's run. And or how many unique values were there in our treatment variable? It was 1 and 2. 1 corresponds to placebo and 2 corresponds to active. Okay, let's take a look at the output dataset which is created. So as I'm no longer interested in seeing the unique values each time I run, I'm just commenting this code, running the code again. Let's take a look at the log. Okay, so there were 41 observations were read. So what does this 41 indicate now? So we have subsetted safety flag is equal to y. Our initial ADSL itself also had 41 subjects. What does this indicate? So all 41 subjects are part of our safety analysis set. Okay, so let's take a look at our TRT totals dataset. Okay, TRT totals dataset. Okay, we have 19 records with a value of 1 in treatment variable and 22 records with a value of 2 in the treatment variable. So as we only have, we'll only have one record per subject in ADSL dataset. What would be, how can we read this? So it is 19 records is meaning that 19 subjects. Okay, 22 records with a value of 2 indicates that we have 22 subjects in treatment variable. Okay, 22 subjects in second treatment. Okay, so now we have got this, and we need this to be stored, present this here as the header count. Okay, so how do we create this? So we have to create the symbols, so we have to create the macro variables. Okay, create macro variables to hold, okay, treatment totals. Okay, so how do we do it? So we can use either proc SQL or we can use our data step with call simple. So as I'm not interested in creating any physical data set here, I am just using my underscore null underscore. Okay, so let me save the symbol names with as. Okay, I'm concatenating a value of n to the value present in the treatment variable. In which variable do I have my treatment totals available? So I have them in my denom variable. The value present in the denom variable row would be on that particular row. Okay, so we have two rows in the treatment totals. So on the first row we have a value of 1. So when this catus is being executed, that symbol name would become as n1. Okay, we'll have a n1 symbol created with the value present in denom variable. What is the value here? So we have 19 subjects in treatment 1. So that n1 symbol would be created and it would have a value of 19. Similarly, n2 symbol would be created when the second observation from treatment totals is being processed. Okay, and the value associated on that row in denom variable is 22. So the n2 symbol will have my 22 value stored in it. Okay, 22 value stored in that symbol called n2. Now I have my symbols also created. Now what should we do? Okay, what should we do? So we have to process our data in such a way that we will get these counts. Okay, so each time we have to get the counts: normal versus normal at baseline, abnormal versus normal at baseline. So it would be a better idea to populate our baseline result across all records of the post baseline. So how do we do that? Okay, so let's process our ADEG dataset. Okay, process ADEG dataset to populate baseline result across all records of that subject. How do we do it? Okay, so first we have to identify which record is baseline. We have seen that. Okay, we have seen that a visit is baseline on the record where a visit is which is baseline result. Okay, so I am using my ADEG01. Okay, ADEG01 where a visit is equal to baseline. Okay, a visit is equal to z. Okay, so okay, a visit is baseline. So in order to avoid checking the value, I can just use my uppercase of a visit is equal to okay baseline. Okay, so now in this data set, what would I have? I will have the baseline records. Okay, I will have the baseline records. So now I need to use this data set. Okay, I need to use this data set and back merge with my ADEG01 itself. Okay, proc data is equal to ADEG01 by u subs id param cd. Okay, let me create a data set called ADEG02. Okay, merge ADEG01. Okay, and is equal to a. So I have identified my base. Okay, baseline records. So how, at what level do I need to merge? So I need to merge it based on subject and parameter, right? So a baseline would be varying per subject per parameter, but I also need to keep my eval C, but rename it as base C. Okay, so eval C on the record of baseline is nothing but my baseline result. Okay, so I have renamed it. So I am merging it based on subject and parameter. Okay, I have done this. Let's take a look at the record structure after I process this. I have run this. Okay, ADEG02. Now if you see the baseline result of each subject. Okay, this is the abnormal, not clinically significant is the baseline result, and that is populated across all records of that subject. Similarly, we have seen earlier. Okay, so these are the records of that single subject. Okay, so the baseline result for this subject is normal. It is being populated across all records of that subject. Okay. So if you see ECA21. Okay, so how many records do we have for this subject? We have 1, 2, 3, 4, 5 records. Okay, what is the baseline result for this subject? It is normal. Now we have subsetted this record and populated this eval C as base C across all records. Okay, that's why we have a normal value which is from the baseline record is being populated across all records. Now I would be able to directly check how many records were there with normal versus okay post baseline normal, post baseline abnormal, or all the combinations. So if I can just cross tabulate with base C versus eval C. Okay, so I have populated my base across all records of that subject. Okay, so and what is the next thing? Let's create okay a few numeric variables. Okay, so as we have to okay, so process ADEG02 dataset to create numeric variables for sort order purposes. Okay, So if you see, so in the table we have to present the normal result first and then abnormal NCS and then abnormal CS. Let's try to create a numeric variable which we'll be using to get this same sort order. So if we are using directly the eval_c variable, what would happen? The A would come before N. So that sort order would not be proper. So what I am trying to do here is I am trying to create a numeric variable. Okay, a numeric variable to hold that value. Okay, set ADEG02 if eval_c is equal to normal. So what were the values like? So it was in all uppercase. Okay, so eval_c is equal to normal. Let's create a variable called result. Okay, result is equal to 1, else if eval_c is equal to abnormal, not clinically significant. Okay, then let me assign a value of 2 to it. Okay, else if eval_c is equal to abnormal clinically significant, I am assigning a value of 3 to it. Okay, so let me copy this and let me similarly create this value for base C. Okay, let me create a parallel variable called B result. Okay, for baseline. Okay, so in this input data set, let's also subset for the required post baseline visits. Okay, so we have seen earlier that wherever the record a visit and value is greater than 6 corresponds to our post baseline records. Okay, we are not interested in. Now we have fetched the baseline information and populated it across all records of the post baseline. Okay, and now we are not even interested in the baseline record because that information which is required for baseline processing has to be merged back onto the individual record that we have done. So I am interested in only keeping this post baseline time points here in this my input data set. Okay, subset records only. Okay, so how can I do that? I can just make use of my a visit n variable greater than 6. Okay, so a visit n 6 was for baseline, so all the records with greater than 6 would become my post baseline records. Okay, done. So I have substituted. So we had like 159 records, of which only 82 records are our post baseline records. If you see, okay, when I filter for post baseline records, I have only 82 records. Okay, what is the next thing we need to do? We need to get the counts. Okay, obtain actual counts. Okay, so how do we do it? So we can use our procfreq data is equal to ADEG03. Now I am interested in fetching the number of subjects with in a post baseline result value within a treatment within each baseline result. Okay, so what are the levels within each time point, within each post baseline result, within each treatment, within each post baseline result. So what should my table statement look like? Okay, within each a visit, so I am using my numeric and character version both. Okay, and then within each post baseline result, let's try to make use of our post baseline result variable, which is the numeric value which we have created. Okay, and then within each treatment, okay, within each treatment we have our baseline result combination. So we have to use our treatment variable and then we have to use our baseline result. Okay, let's try to save the counts to a data set named counts01. Okay, count01. As we are not interested in the percent variable, let's drop the percent variable. Okay, let's run this and see how our dataset structure would look like. Okay, so let's try to use our okay, so I have run the procfreq. I'm opening my okay. So here if you see there are few subjects who did not have baseline. Okay, There are few subjects who did not have baseline result. Okay. For the purpose of this table, so we are interested in only grouping the subjects who have a result. Okay, who has a result. So we are not presenting any post baseline missing or column with baseline result as missing. So what should we do? So we should also consider only those subjects who have both baseline result and post baseline result available. Okay, baseline result available and post baseline result available. So how can we filter for those records? So post baseline records we have subsetted using a visit n, and then we are interested in subsetting the records with non-missing result and non-missing baseline result. Okay, so we have subsetted this. Okay, so we have to get the count because this table allows for only to present the columns wherever the value is not missing. The value has to be either normal, abnormal, NCS or abnormal CS in post baseline result. The value in baseline result has to be only normal, abnormal, NCS and abnormal CS. Okay, so it is only these result combinations can be presented in this table. So as we have few subjects with baseline result missing, so we are excluding those subjects for generating this table count. Okay, so we are, as we cannot group those records with baseline result as missing anywhere in this table content, so we are considering only the subjects who has a result and excluding the subjects who do not have the baseline result populated. Okay, so and we have obtained the counts. Okay, let's try to take a look at our count 01 dataset. Now we have our, so what does result 1 indicate? So the normal result, okay, in post baseline with baseline result normal, okay, which is 4. This is what is there in normal to normal at week 4. Baseline normal, post baseline normal at week 4, we have 4. So we have got this counts now. Okay, we have obtained the counts, required counts. Okay, but if you see, so what are the total number of possible combinations? 3 records, 3 combinations, like 3 weeks we have 3 multiplied by 3, 9, 9 multiplied by 2, which is our 2 treatments. Okay, 18 multiplied by 3. So we should have, if all the possible combinations are there, we should have had like 54 rows here, but we only have 25 rows. What does this indicate? If you see, so 1, 2. So there is no 3 result. Okay, where is that? Okay, if you see in treatment 1, we only have 1 record with result 2. So but what is expected? We are expected to have treatment 1, okay, result 1, 2, 3, 4, right? In treatment 1, we have to present row at week 4, we have to present normal, abnormal NCS and abnormal CS as well with 0 counts, as these rows are not present. But when we are getting the count, so we are not getting those rows. So what should we do? We should create our dummy rows to create the full template of this structure. Okay, this structure. So let's try to create that. Okay. Create dummy rows. Okay, create dummy dataset to hold all levels. Okay, all levels. So here I'll not know, say for example here I have 3 time points. Okay, I may have more time points in future data, so I am fetching the time points available. So these are fixed values. Okay, in the result it is fixed. So normal, abnormal and normal, abnormal NCS and abnormal CS are fixed values. So here also in baseline result these are fixed, because but in time point I'll not know whether there will be more visits added later on or not. Okay, so for that way, what I am trying to do here is I am trying to fetch the unique values available within each treatment, okay, within each time point, and then build my dummy data set. Okay, so how do I do that? So let me fetch my, so only thing which may vary is, only thing which will vary in this table is, so my treatments are fixed, my baseline values are fixed, my post baseline result number of rows for each visit are fixed. Only thing is like these values may vary. Okay, there could be more rows or there could be less rows. Okay, so for that what I'm trying to do is, like, instead of doing it like dummy for all the week 4, week 12 and week 16, so I am trying to fetch the unique values present within the time point variable and building the rest of the dummy. Okay, So building the rest of the dummy. So how do I fetch my unique visit values available in the data? Okay, so I can use my ADEG03. Okay, ADEG03. Okay, I can create a dataset called dummy and keep only a visitant and a visit. Okay, a visitant and apply node key at what level? A visitant and a visit level. Okay, what would happen now? I would get the unique values present in the a visitant and a visit combination in the ADEG03. So if I have week 4 and week 12 only, so I would only get 2 rows here. If I have week 4, week 12 and week 16, I would get 3 rows in this data set. So this has become dynamic now. Okay, so based on the number of visits available in my input data set, I'll get all those visits into my data set. After that, okay, after that, what do we need to do? We have to expand the record structure. Okay, we have to expand our record structure. Okay, so within each visit, how many records do I need to have for result variable? So the 3 post baseline results. So which variable have we used now? So we have created a numeric variable called result. Okay, numeric variable called result to hold these 3 normal, abnormal NCS and abnormal CS values. So what are they? So I am trying to do result is equal to 1 comma 2 comma 3. Okay, and then okay, within each result, okay, within each post baseline result, so I need to have 2 treatments, right? So I am writing another loop. 2 treatment is equal to 1 comma 2. Okay, within each treatment, okay, I need to have 3 baseline result columns. So what I'm doing here, do b result, okay, because we have created a numeric variable parallel to the base C result, so I'm using that one. 3 levels. Okay, so if I output, what would happen? So I would have my, for each visit I would have 3 post baseline records. Within each post baseline value I would have 2 treatments, and within each treatment I would have my 3 post baseline result columns. Okay, so those structure I have created. So as we have seen earlier, so 18, okay, 18, 18, 18. So we have to have 54 records in this dummy. Let's see if that is working properly. Okay, see. So 3 visits, okay, 3 visits multiplied by 3 results. So 9, 9 multiplied by 2 treatment unique values, 18. 18 multiplied by 3 column, 3 levels for our baseline result. So we have total 54. Now we have our full template ready. Okay, so what do we do? So we merge our dummy and actual counts. Okay, dummy and actual counts. Okay, merge dummy and actual counts. Let's sort our data. Proximate data is equal to dummy 02. Right, how do we sort it? Okay, let's sort it the way how it is present. A visit and a visit and result. Okay, treatment and then B result. Okay, sort data is equal to, so we have our actual count stored in count 01 data set. Again the same sort order, result, treatment, B result. Okay, so let's create a data set called count02 by merging count01 n is equal to A and dummy 02 n is equal to B. Okay, so by a visit and a visit, result, treatment and B result. Okay, so let's run this and see. Okay, so if you see 25 rows were present in actual data, 54 rows were coming from dummy 02. We have done a full merge. Okay, so let's do my visual inspection. So we did not have any row for week 4 in treatment result 1 in treatment 1, okay, with B result 3. So we have the count missing. What does this missing indicate? So it indicates that there are 0 subjects. Okay, let's count is equal to, let's set the count to 0 wherever the count is missing. Okay, now we have our full set of counts ready. So what is the next thing we have to do? We have to calculate the percentages. Okay, calculate. How to calculate the percentages? What do we need to do? We need to fetch our treatment totals into our counts data set. How do we merge? So we have to merge this at treatment level. Okay, so I'm just sorting my data set, okay, by treatment. Okay, let's sort our treatment totals data set also based on treatment. Create a data set called count03. Okay, by this at merging counts 02 and our TRT totals data set by treatment. So what would happen across all rows of that treatment? So the denom value would be populated. Let's run this and see. Okay, let's run this and see. So where is it? Okay, if you see across all rows, across all records of that treatment, my treatment total is populated. So 22 number of subjects are available in treatment 2. So I have my denominator. What is the next thing we do? We calculate the percentage. Let's do that in a separate set. Okay, counts 04, counts 03, and okay, few people directly do the percentage here, but I generally try to keep it separately. Okay. Okay, there is nothing wrong if you calculate the percentage here itself. Okay, let's concatenate the count and percentage into. Okay, so did we present 0%? If you see here, the percentage is being presented here even when the count is also 0. So earlier, so we have presented only 0 when the count is 0, but in this example we are presenting the percentage symbol when the count is also 0. Okay, so we need not check whether the count is 0 or not while trying to create the CP variable. We can directly use, okay, count of 3 dot. Okay, and then so how do we calculate the percentage? We divide count by denom variable and multiply it by 100 and convert it into character using 5.1 format, and then we use our percentage symbol and the closing parenthesis. Now we have our count percentage variable created. Only thing is, like, so far we were using only the treatment column, treatment values as columns, but we have treatment and baseline result as columns now. So each treatment and baseline result as columns. Okay, only thing is, like, while transposing we have to make sure that within each treatment these individual baseline result columns are becoming columns. Okay, values are becoming columns. So how do we do that? Okay, how do we do that? Okay, so transpose the data such that your treatment baseline result values within each treatment become columns. Okay, so this is a little newer thing for us. Okay, so which columns do we need to keep as columns? The visit column, the post baseline visit column, and rest of the things should become columns. Okay, so proc sort data is equal to count04. Let's sort it this way. Okay, what is the sort order? Okay, a visit n by a visit n, a visit. So our result column is nothing but our post baseline result. Okay, and then treatment, and then the result. Okay, so out of these columns, so which columns are we interested in keeping as columns? Proc transpose data is equal to count04. Let's try to create a data set called count05. Okay, and let's give a prefix of group underscore. Okay, group underscore to the newly created variables. Okay, so I am interested in keeping the visit level information as columns. Okay, I am also interested in keeping the post baseline result as column. Okay, as a column. So I do not want to transpose that. I am keeping it in column. Okay, so what is the variable I am interested in transposing? The CP. Okay, but what variables values have to become my column names now? So earlier we were using treatment alone. Okay, now if I am keeping my B result as well, I am using my two variable names in ID variable. So what would happen now? Treatment 1, B result 1, treatment 1, B result 2, treatment 1, B result 3. So these are the possible combinations now. So that combinations would become my column names now. Earlier the values were either like 0, 1 or 1, 2. Okay, the values in treatment variable were 1 and 2. The 1 would have become underscore 1 as the column name. Okay, and 2 would have become treatment 2 column. Okay, but now we have used two variables here. The two results combinations would become the names of the columns. So that way, how many values are there now in treatment variable? Unique values are 2, that is 1 and 2. And in B result we have three unique values, 1, 2 and 3. Okay, so on a particular record we would have only one combination. It would be 1 1 1 2 1 3 2 1 2 2 2 3. Okay, so we will have the new columns created in this combination: 1 1 1 2 1 3 2 1 2 2 2 3. Okay, so and for those variables we are giving a prefix of group underscore. Let's try to run this and see. Okay, let's try to run this and see. Okay, so I have transposed. Okay, that is our dataset count 0. Okay, now if you see, so group underscore is grp underscore is the prefix which I have given. So after that we have two digit number 1 2 1 3. Okay, 1 1 1 2 1 3. So what does this first character in this two digits like indicate? It indicates the treatment value. Okay, it indicates the treatment value. Treatment 1, baseline result 1. The second character indicates the baseline result. Okay, treatment 1, baseline result 1. Treatment 1, baseline result 2. Treatment 1, baseline result 3. Okay, similarly treatment 2, baseline result 1. Treatment 2, baseline result 2 and baseline result 3. Okay, so is this not the same structure as what we needed? The result column has to remain as column. Okay, and then the post baseline columns, like in the columns here, has to be within each treatment: placebo, normal. So what does 1 1 indicate? So placebo, normal. What does 1 2 indicate? 1 is placebo, 2 is abnormal NCS. Okay, what does 1 3 indicate? Placebo and abnormal CS. So our record structure is same as the final one. The only tricky thing here is that only new thing is what I would say. Okay, is to use how to use two variables in ID statement. Okay, we have used two variables here. So far we only had the treatment columns presented as columns, but we have more combinations now. So what did we do? The rest of the process remained same, and only thing is we have added two variables in the ID statement, so that the combination of these two variables would be used as the names of the variables, names of the new columns being created. Okay, so we have our final structure ready. So what is the pending thing now? We have to create our report. Okay, generate report. So we have one additional processing required. Okay, so far we have the result variable values, okay, as 1 2 3. So let's create a variable called label. Okay, to assign, like 1 is normal, 2 is abnormal NCS and 3 is abnormal CS, right? So let's create that. Okay, let's create a data set called count 06 set count 05. I'm creating a new character variable, so I am writing a length statement, and let's say I am assigning a length of 20 to it. Okay, length of 20 to it, length of 20. So if result is equal to 1, then label is equal to, so this corresponds to our normal. Okay, else if result is equal to 2, then label is equal to, so what was the label to be presented in the report? It is abnormal NCS. Okay. Else if result is equal to 3, then label is equal to, sorry, abnormal CS. CS is for clinical significant. Okay. Now I have my things ready. Okay. So generate report. Okay. So which procedure do we use to generate the report? We use our proc report. So we name the input data set using data is equal to option. Let's use a line size of 150 and let's use headline option, which writes a blank line between, which writes a solid line between my header portion, okay, column headers and my data portion. And let's also use our head skip option, which writes a blank line between our column header portion and the data portion. Okay, so I have done that. So what are the columns that have to be printed? Okay, so we have our columns to be printed or a visit, okay, and then label and all the columns which are corresponding to this. Okay, so what are they? Let me group them here. Okay, grp 11, okay, grp 12, and the third column is grp 13. Similarly, we have group 21, group 22, group 23. Okay. Okay. So what should be the, so we have to sort our records based on a visit n value. Okay, so I am using a visit n and I am also using my result variable, but I have to sort the variable like records based on a visit n value but do not print it. So what is the keyword for asking SAS not to print that column? So no print. So what is the keyword to ask SAS to sort the observations based on a particular variable? So it is order. Okay. And the second thing is, let's define a visit. So what is the column name for column header for visit time point? It is time point. Okay. So it is time point. Okay. So let's use a width of, okay, let's use a width of, say, okay. And then next is our result variable. Do we need to print it? No, we only need to use it for sorting. Okay, so we need to use it only for sorting. So I have done that. The next thing is we have to use our present our label column. So what is the label for label column? Post baseline result. Okay, post baseline result. Okay, let's use a width of 25 for it. Okay, so next comes our define. Okay, group 11. Okay, group 11. So what is the column heading for group 11? It is normal. Okay, okay, it's normal. So let's use a width of, let's say, 10. I think 10 should be sufficient. 5. Let's use a width of 15. Okay, fine. Group 1 2. So what is the column heading for group 1 2? It is abnormal NCS. Okay, let's use a width of 20 everywhere. Okay, which is equal to 20. Define group 1 3. So what is the column heading for 1 3? Abnormal CS. Okay, width is equal to 20, let's say. Okay, so I'm just copying this and pasting it and changing it to group 2 1 2 2 and 2 3. Okay, now I have done this. Okay, let me run this preliminarily and see how it is working. Okay, I think width 20 is more here, so I can just reduce it to 15. So I'm just trying to see what is the best possible width. Okay. See, now we have our report looking a little better. Okay. The thing is now we have to print, like if the week 4 is repeated on multiple rows, we have to print it only once. So how can we do that? We have to just mention that as an order variable. Okay. So on any order variable, if there are more than one record within the same value, okay. So what would happen? Only the first occurrence would be printed. All the subsequent occurrences would not be printed. So I have used my order variable. Let's run this entire code and see the report. Now, if you see, we have week 4 was present on all these rows. Okay, so it is printed only on the first row now. Okay, only on the first occurrence. Now we also needed a break after each visit. How can we do that? We can use our break statement. Okay, break after which column? It is a visit column. I need a blank line. So how do I mention it as a blank line? Break after skip. Let me run the entire code and see. Now we have our blank line created. Okay, so we have our output looking a little better. So what is pending here? So if you see above this column headers, we have another heading. Okay, above this column heading, we have other headers. So how do we do that? Okay, so here I am indicating that okay, these are one group. Okay, this is a group. Okay, these three variables are being grouped together. Okay, here for each individual header, okay, I have used within the define. Okay, so within the define statement, I have provided my lowest level header. Okay, what do I mean by lowest level? So this is top level and next level and then the lowest level. So the lowest level headers are being given here in the define statement. Okay, so I am trying to create my, these are the treatment columns corresponding to my treatment, right? So I'm giving my split character as well. Okay, and then I need to give my n is equal to, and then okay, so I have given this heading. Okay, similarly I'm giving a label of okay active and n2. So what would happen on top of these three? So this would be written as header. Okay, so I need to indicate that these three variables are grouped. Okay, so I am using parentheses to group them. Okay, so I am giving this header even before mentioning the variable name. So what would happen? The value on this would be written on top of these three columns, which is the requirement. Okay, so we have three columns. On top of it, we have to have this placebo. Okay, and n is equal to 19 written. So we have written that. Similarly, let's try to run this and see how this works. Okay. Now if you see, okay, as I have not given the split is equal to option on the proc report, that symbol is being written, okay, directly onto the report. Okay, so let me give that, let me indicate to SAS that, okay, split is equal to, so what is the symbol I have used for split character? So this is what I have used. Okay, so now you see placebo n is equal to 19, normal, abnormal NCS, abnormal CS, normal, abnormal NCS under active. Okay, what is the thing that I need to change here now? So I need to have a solid line written below this one, solid line written. So and I have one more thing above this thing. I need to have this result coming as baseline result. Just before that, we'll just see how to get this solid line with this below this point. Okay, so I just need to indicate it this way. Okay, I need to give an underscore before the first value and after the last value. Okay, so let's see. It has been quite some time I have used this option. Let's see if it works. Okay, it is not coming. No, I think then it has to be. Now you see we have got a solid line. Okay, So though this is not appropriate, okay, and we have a solid line between the treatment total and this one. Okay, though this is a little different. Let me, I'll explain you a little later on how to get this on a separate line. Okay, so here I have got something meaningful. So on top of these two, I need to present my baseline result. Okay, so for in order to print a header just below above these three columns, I have used parentheses to group these three columns and then use this header. Okay, so now I need a header above this. Okay, so I am grouping all these columns. Okay, I am grouping all these columns and then giving, okay, okay, and then giving this one. Let's see. So I am indicating that this is my first header. Within that I have another group of columns which takes a header above it, and the second group of columns which takes a second header. Okay, let's run this and see. Now you see I have my baseline result heading coming above it, and then the treatment heading, and then the individual headings under each of them. So our report is now looking very similar to the one which we have generated earlier. Okay, so this is how we create this table.